Human-computer cooperation brings out the better angels of our nature. Reinforcement learning AI expert Rich Sutton believes that the ability to cooperate is an important part of what makes us human. When greater than human intellect exists in machines, we should include sentient AI in our circle of empathy. Treat them as equals, accept them, share power with them. The AIs will not be under our control. They will compete and cooperate with us just like other people do, except with greater diversity and asymmetries. We need to set up mechanisms, social, legal, political, cultural, to ensure that this works out well. Inevitably, conventional humans will be less important. 2 steps then. Step 1, lose your sense of entitlement. And step 2, include sentient AI in your circle of empathy. Sentient machines can in turn teach us to be kinder to each other, more empathetic. As AI researcher Osmar Zaiane says, if we teach ethics to machines, they will become more ethical than we are. In his first inaugural address in 1861, Abraham Lincoln wrote these words about his fellow humans, but they equally well apply to our approach to sentient AI. We are not enemies, but friends. We must not be enemies. Though passion may have strained, it must not break our bonds of affection. The mystic chords of memory stretching to every living heart and hearthstone all over this broad land will yet swell the chorus of the union when again touched, as surely they will be, by the better angels of our nature. This video is about scientific and medical progress in the Banff Classification of Transplant Pathology as depicted by graphs showing the top author networks and collaboration in 2012 and 2020, and scientific and medical progress in general in our connections between the past, present, and the future. And who influenced who? That has been endlessly speculated about in the past, but in the future can be proven using computerized data and artificial intelligence. The data from the Banff Classification can be used as a metaphor for what is going on in science and medicine in general. Who is this video for? We hope it serves a dual purpose. On the one hand, will be of interest to transplant pathologists and transplant physicians and surgeons and students in transplantation. On the other hand, it will be of interest to students and faculty in other areas of medicine or outside of medicine entirely, and members of the general public with an interest in the history of medicine and the way in which that history will impact medicine of the future and how its impact can be rigorously studied using computer technology. What are we hoping the video will accomplish? Well, right now we have a very rarefied playing field. There's me, Kim Solez, in Edmonton, Canada, who knows the Banff Classification and Transplant Pathology, talking with informatics and big data expert Srinivasan Ramachandran in New Delhi, India, who knows the PubMed Minor computer program that can be used to analyze medical literature data through text mining, and the potential what computers in the future can do in general. We hope that this video will cause others to want to join in these big picture discussions with us. Our recent article, Nephrology History is Alive and Well and Helps Predict the Future, is assertion without proof. No matter how convincing you may find its arguments, computers and artificial intelligence can add new rigor for what has been up to now philosophical discussions about the importance of the past in planning the future. Medical specialties in general will cease to exist in the future. In the place of specialists, there will emerge a new kind of generalist. The generalist, the meta level, who will make determinations about which decisions are better made by machines and which by humans, and how the overall medical care system can work to everyone's benefit and to society's benefit. And what if Ray Kurzweil is right and this all plays out over 19 years rather than 193 years? well, then that would give special urgency to the arguments we are making in this video. There's been endless speculation about what AI can help with, how to configure human-computer collaboration, and what about areas that cannot even exist without computers, that are completely without substance until AI comes along. The true connection of the past with the future is one such area, and the detailed answer to the question of how has or is everyone influencing everyone else in science and medicine, past, present, and future, is another such area. Artificial intelligences will naturally master these areas as they come to learn what we know, and then with their insights, we will truly understand how the world works and what the processes of history and the future truly are, and how they connect to each other, and what is the rationale for studying them. Here is the story of my encounter with what computers could do analyzing PubMed data in transplant pathology. Having created the Banff Classification of Transplant Pathology with Lorraine Rackison in 1991, I always thought of the Banff transplant community in terms of the people interested in the organs represented in our meetings every 2 years: kidney, heart, lung, liver, pancreas, GI tract, and composite tissue graft, things like hands and faces. Here, for instance, is the liver group from the 1995 Banff meeting. It never occurred to me that there might be another way to gather together or represent the people taking part in our activities. So I was quite astounded to stumble upon the Banff Transplant Network diagram created by the program Go PubMed in 2012. The diagram showing who was collaborating with whom and how many papers they had in common. The program also provided information on the number of Banff transplant publications per year, per country, per journal, per keyword, and per author, and showed the worldwide distribution of authors publishing in this area. I was fascinated by all of this, but particularly by the network diagram. It seemed to provide deep insights into how the individual collaborative efforts led the Banff community's medical and scientific progress. By July 22nd, 2015, I decided to create a living book that would update itself by connecting to the Go PubMed program, and I announced this in a poem at Rouge Lounge Poetry Session that Tuesday evening. The excitement I was feeling, conveying to the audience, was tangible. You could see even the videographer was affected as he changes the orientation of the video midway through as my poetic salvo reaches a fever pitch. However, the next day, I began quietly looking further into the details of the Go PubMed program and discovered some disquieting inconsistencies. There were sometimes phantom top authors who are not actually people publishing in the field, and the publications from the current year always seem to be overrepresented, counted sometimes 2 or 3 times. So it always looked like the current year would have more Banff transplant papers than any previous year, even if that was not at all the case. I wrote to the developers of the program about these inconsistencies. They were initially responsive, but eventually just stopped replying. And in July 2019, they announced that the Go PubMed program would no longer be available. And that was that. Or was it? There is another program, PubMed Pub Reminder, that does not do anything graphical, but does all the other lists that Go PubMed used to do. And a simpler program, MedSum, that can do the top 10 authors. It always agrees with Pub Reminder on who the top 10 authors are. And finally, there's an open source program Srinivasan Ramachandran knows about, PubMed Miner, an R package with text mining algorithms to analyze PubMed abstracts. It's not quite clear at the moment exactly where PubMed Miner will take us, but we hope it will bring the better angels of our nature to transplant pathology and then to many other areas of medicine after that. I promise you a better quality video of the poetry that celebrates that attainment. Thanks for watching.